There is a very interesting question in a very famous book by M.S. Chauhan for organic chemistry, and this is relevant to students who are preparing for JEE Advanced or students who have deep interest in stereochemistry. So the question is, how many pyramidal molecules are possible with these structures C, A, B, E, D? Okay, so let's dive into it. There are many layers to understand this. First thing is, like, one can think by pyramidal molecule, one can think like molecules like ammonia. Ammonia, the shape of ammonia is called pyramidal. So this kind of a shape. Why is it called pyramidal? So what is a pyramid? So in terms of geometry, pyramid is something which has a polygonal base, and then there is a point not on this plane, which is the base. The base is planar, a polygon, and there is a point not on that plane, and you can connect all these vertices to that point and you can draw a pyramid. For example, right here I drew a pyramid with a quadrilateral base. You can make a pyramid with triangular base. So the shape of ammonia is pyramidal because if you join all these atoms, the outside atoms, you get this pyramid there. So the shape is called pyramidal. And if we are thinking about this kind of a shape, then what is possible, that there is one lone pair in this shape, because if that lone pair is not there, like suppose in ammonia there was suppose you have ammonium ion, then that lone pair is not there. Instead, that lone pair has been attacked by H positive and NH bond has been formed there. So now this shape is not called pyramidal, this shape is called tetrahedral. Why this shape is called tetrahedral? This is very interesting, because if you connect all the exterior atoms like this, you get, somebody can say, I still get a pyramid, a triangular pyramid, but this triangular pyramid is a little bit special because all the sides are similar, and because all sides are not similar, exactly same in length, so that kind of a pyramid is a regular tetrahedron, which has a lot of significance in geometry because it's one of the platonic solids. So it's like whenever I teach this, I have the feeling that people who are writing the tables in chemistry doesn't have a lot of knowledge about mathematics, geometry, like what shapes are what, because a tetrahedron, a regular tetrahedron is also a pyramid, and it was possible that somebody could have called this pyramidal. But no, we have, if you have a lone pair, like if you have ammonia and you have a lone pair and you have three hydrogens like this, then you call this shape pyramidal. And if you don't have that and you have a bond instead of the lone pair here, then you call it tetrahedral. And a tetrahedral is, the shape tetrahedral is in a way like very similar to pyramidal, because a tetrahedron is also a pyramid. So, but respecting the lingo of chemistry, let's go into this, dive into this question, and let's suppose that by pyramidal molecule, we mean this kind of a molecule with lone pair. And so we can make one of the attachments a lone pair. So E is a lone pair, which is not done normally, but in NCERT books also for lone pair, the letter E is used. So who knows, maybe this is the situation. So if you try to solve it like this, if the molecule is like this, then this is very simple, because this is in you can feel that this is like chiral carbon. It has all four different attachments, and it's in tetrahedral geometry, and that's why you can have two isomers. And if the molecule can invert, like 3-degree amines, in 3-degree amines with all three different alkyl groups, if you have that kind of a situation, then you know that the lone pair, the molecule can invert and the lone pair can come on the other side of the molecule, and the two isomers are then not isolatable. They can interconvert among themselves. So, but still you can make these two molecules and you can say the answer is either 2, if inversion is not possible, and if inversion is possible, then the answer is 1. But neither 2 nor 1 is the answer to this question. So the word pyramidal means something else. What can the word pyramidal then mean? So as we discussed, maybe it means tetrahedral, because a tetrahedral is same as pyramidal in some respect, except for the sides being exactly equal. And also there is one very interesting difference. Like if you see the shape is pyramidal. Just a minute. If you see this pyramidal shape, not like these, I can make this in plane, and this is in the front, and this is in the back, and this is a lone pair. And then if you make this tetrahedral shape, then you have n positive here. But look at this shape. You join these atoms which are on the outside of the shape, which are like outside, and you join them and you make a shape something like this. This is pyramid. This is also a tetrahedron in a way. But here you get a regular tetrahedron. Not only this is the difference, that the regularity of size, not only that, there's one very interesting difference also, that the fifth atom here is at the center of this figure, but here there is no fifth atom. Only there's nothing at the center, right? There's nothing at the center. Well, it's just good to notice these things. And all of these things are coming because maybe people who are writing these tables and these books, they are not aware of, or maybe they are aware and are not sensitive to use the words correctly. Anyways, so tetrahedral shape, maybe bipyramidal, the book means tetrahedral shape, and if that is the shape, then you can make two different molecules, of course, and you can't even interconvert between them. They would be mirror images of each other, right? So you can see the image of E here, the image of A here, D here, B here. For more details, you can see more easier videos like videos on stereochemistry, in which I go into more detail about these things, these simple things but beautiful things. But now one can understand that there are two molecules here possible, but that is of course not the answer. So what is the answer? Answer is something very interesting, which we will get if we understand what the word pyramidal could mean. What is pyramidal? Because there are so many pyramids, but maybe the most famous pyramid they are talking about square pyramidal, because the pyramid in Egypt is a square pyramid. It's a pyramid with a square base. It has one vertex here, one here, and one at the back, which I am not able to show here. So it has a square base, and then the apex here, the top of the pyramid here. So maybe this kind of a pyramid is being asked about. So if this is the case, then let's see what will happen. So then you can have many different kind of molecules. You see, suppose like one more important thing also, when I represent this like this, this shape like the square pyramidal shape like this, you can feel that this is the apex, this is at the top, this is the square base, this is the square base, right? And C is not on that base, this is on the top, this is somewhere like here, C is here, and let's say if A is here, it means A is here, if B is here, it means B is here, if D is here, then D is at the bottom, which I can't show, and on the back actually, and if E is here, E is here. So this is how I will represent a square pyramidal shape. And then we start thinking about how many different kind of molecules are possible. So if you go random, then you will go completely random, and you will never be able to figure out how many of them are possible. But going random, you can see that there are different molecules possible. For example, this molecule, the first molecule right here, is different from the second one, because opposite to the A you have an E, and here opposite to the A you have a D. And you, no matter how you rotate the other molecule, you can't make it similar to the first molecule. You can't make it superimposable to the first molecule. So you have different possibilities here. So two possibilities. Third possibility here also, A and B are opposite. You see, A and E were opposite, then A and D are opposite, and A and B are opposite. So 3 possibilities I showed you. But are only like, is the answer only 3? So somebody can, this is very similar to what happened with square planar geometry. In square planar geometry, we had the C, this central atom in the plane. So you had C something like in the plane. There's no need to draw wedge and dash now. In square planar geometry, you have A, B, D, E like this, all in the plane, and the C also is in the plane of that molecule. And if that is the case, we know that there are 3 molecules. If you don't know, then you can look it up. This is very simple to understand. The square pyramidal geometry is very simple, and you have 3 molecules there. So one might be thinking that this is the case with square pyramidal also, but no, just because the C is not in the plane, it's not in the plane, that's why we have more options here. So you can't do that. The answer is not 3. So what I'm going to show you now, suppose this is the same base. This is the same base, right? You have A here and B here and E here and D here on the base. This is the base plane. We have same base plane here. You have A here, just like before, A here, B here, B here, E here, E here, and D here, D here. We have the same base plane, but the C is now not in the plane. It's on one side of the plane, while in the other molecule, the C is on the other side of the plane, right? And if it was a square planar geometry, then you would have said that these two are the same molecules, because the C would have been in the plane and then they would be superimposable, right? But this is not the case. The C can be on the either side of the plane. Looking like this, you can understand that each single case in square planar geometry will give rise to 2 cases in square pyramidal geometry, if only we can prove that these two are non-superimposable. This and this are non-superimposable. These two shapes, they might just be the same. But let's rotate this one and then see what happens. So when you rotate this, you get something like this. So I couldn't rotate the letters, so I get an idea by first rotation. Just a minute. I get an idea where it goes, and then I drew the second molecule after rotation, and then I compare them. Let's bring them together. Then you see the C is at the top, the C is at the top, and then what happened to the base? So now the A is here, B is here, E is here, and D is here. And can you superimpose them? So opposite to A you have an E, so opposite to A you have an E on the base, opposite to B you have a D, opposite to B you have a D here, but the sense in which you move from A to B to E to D is clockwise here, and the sense in which you move from A to B to E to D is anti-clockwise here, and you can't change it by rotation. You can move the molecule and as you can move the molecule, translate or rotate the molecule, but you would never be able to superimpose them. There is much technicality when talking about clockwise and anti-clockwise, because it depends on the observer, where the observer is. But I'm not going to go into that to confuse you more. But I guarantee you that you wouldn't be able to superimpose these two molecules ever. So from here one can reach to the answer that the answer is 6. I will explain in a different way also, and this different way is like, suppose this kind of logic I have been using in my other videos also, using the principle of superimposition. Suppose you have infinite such square pyramidal molecules with C at the up position. So you have infinite these kind of molecules, the structure will remain the same. You will have C, A, B, E, D. Okay, the structure will remain the same, and the geometry will also be the same, square pyramidal, but you can arrange A, B, E, D in many different ways. So suppose you have these kind of infinite molecules, and then you start checking like which of how many different kind of molecules are possible here. So what I say, like suppose you have these infinite, so many different molecules. So what you can do with all of these molecules is that you can rotate them about the apex. You can rotate them about, let's say this is the apex, so you can apex, and you can consider an axis passing through the apex and the midpoint of the base and then down there, and you can rotate the molecule about that, right? So you can rotate the molecule about that, and using a few instructions we will figure out that there are 6 such molecules possible. And the first instruction is like rotate all of them to bring A on the front left. For example, here A is on the front left, so I want to bring here in this molecule also, I want to have A here, just to check if it is similar to the first one or not, you know. So we are trying to superimpose them. So let's bring the A in the second molecule, let's bring the A on here. So you see that all other these atoms will move in this fashion. So yeah, and then what do we see? We see now the first 2 molecules. Let's see, A and E are opposite, A and E are opposite, and B and D are opposite also in the first 2 molecules. Don't think about the rest of them, the first 2 molecules, let's think about that. So what do you see now? That the A and E are opposite and B and D are opposite. Same thing here, A and E are opposite, B and D are opposite, but the sense in which you move from A to B to E to D is different. So these 2 molecules are different. Then let's move on to the third molecule, and let's bring the A on the front left. And now we have brought the A on the front left, and we have A and E opposite and B and D opposite. And the sense from A to B to E to D is anti-clockwise, which is same as the first molecule. This molecule is superimposable with the first one. So let's not take this and remove this. Let's think about the fourth molecule. So the A is already at the front left position. I don't have to rotate it, and then I can see now that opposite to A I have a B. Opposite to A I had E before, but now I have a B, and this is a new molecule. So let's keep it, and then let's move on to the other one. Now let's rotate them, bring the A to the front left, and opposite to A I have a B here, and then I get a different molecule from the third one, because this one in here you have A, B, E, D opposite. Here also you have A, B, E, D opposite. But what is different? The sense in which you move from A to D to B to E. Here A to D to B to E. Remember, this is anti-clockwise, and from here A to D to B to E is clockwise, and these 2 are different also. So similarly, you can get a feel that what would happen next. Then you will have molecules with A and D opposite, and you can figure it out that you will have 6 possible molecules like before, right? So the summary is that by pyramidal here, M.S. Chauhan meant square pyramidal, and that's why there is this confusion, like what is the, how to reach to the answer 6. So if the question, if it would have written that the geometry is square pyramidal, I think many more students would have been able to crack this question. So square pyramidal and this kind of a geometry, and you will get 6 molecules, and you can see that you will get 3 pairs of enantiomers also. So if you take A, B opposite and E, D opposite, right, the other molecule in which A and B were opposite and E and D were opposite, if you arrange them in a way, you will see that one of them is the mirror image of the other. So I have shown you right here. So this you can do with all the pairs. You will get 3 pairs of enantiomers. 6 molecules possible. Thank you for watching.